Dear friends, our topic is continuity of functions. Let us consider that a function y is equal to fx be a real valued function, and this function fx is defined at x is equal to a and in its neighborhood. So at the point x is equal to a, we draw an altitude here. So this one is f of a. Okay, let us consider that this height be y0. Okay, so friends, if some positive or negative increment, it is immaterial which kind of increment is imposed on x. Say delta x is given to x and it assumes that x is equal to a plus delta x. X is equal to a plus delta x, and our curve is y is equal to fx. Y is equal to fx. Now friends, we again draw another perpendicular at the point x is equal to a plus delta x, and this altitude is f of a plus delta x. Again we consider that this height be on y-axis be y0 plus delta y. Delta y is the increment in y and delta x is the increment in x value. Okay, so we find that y0 plus delta y is equal to f of a plus delta x. F of a plus delta x. Mark it 1 and this one as 2. So friends, we see that from the given function y is equal to fx, we have two conditions. One is x is equal to a plus delta x, another one is y0 plus delta y is equal to f of a plus delta x. Friends, here we find that from the very beginning condition that at the point x is equal to a, the height is y0, and also on this curve this is f of a. So we can write y0 is equal to f of a. Mark it 3. Okay, so now subtract 3 from 2. So subtracting 3 from 2, we get y0 plus delta y minus y0 is equal to f of a plus delta x minus fa. Okay, so y0 is cancelled. We are getting delta y is equal to f of a plus delta x minus f of a. Friends, we mark it 4. Now friends, one thing is very important. A function y is equal to fx is called a continuous function at x is equal to a if it is defined at x is equal to a and in the vicinity of a, and if limit, this is important, limit delta x tends to 0, delta of y is equal to 0. This is very, very important. Again I repeat, this function y is equal to fx is continuous at the point x is equal to a if limit delta x tends to 0 of delta y is equal to 0. Now friends, why do we write this one? This is important. You see that the change in the x value is delta x, that is the increment in x value, and simultaneously on the curve also we find that the change in y is also delta y. Now when delta x is tending to 0, then delta y will also tend to 0. For this, the function will be continuous at the given point x is equal to a only when limit delta x tends to 0 of delta y is equal to 0. Okay, now friends, we substitute. We can write here a limit delta x tends to 0 of delta y. Delta y is this one, f of a plus delta x minus f of a. So this is equal to 0. this is equal to 0. So friends, we can write now a limit delta x tends to 0, f of a plus delta x is equal to f of a. Okay, now at the earlier point we considered in equation 1 that x is equal to a plus delta x, incremented point, okay, a plus delta x. Now when delta x is tending to 0, since x is equal to a plus delta x, okay, now when delta x is tending to 0, this is delta x, when delta x is tending to 0, obviously x is tending to a, x is tending to a. So we can now write limit x tends to a of f of x, a plus delta x is equal to x is equal to f of a. Friends, this is actually the definition of limit x tends to a of fx is equal to fa. Now we shall discuss this one also. Friends, if given increment is positive, that is your delta x is plus h, say, okay, now we consider this one, limit x tends to a of fx is equal to f of a. Now suppose delta x is equal to positive h, which is greater than 0, okay. So in this case, what can we write? We can write a limit h tends to 0, f of a plus h is equal to f of a, isn't it? Since delta x is taken a positive quantity. But if the increment is negative, that is delta x is equal to, here we write this way, delta x, okay, delta x is equal to negative h, which is less than 0, then we have to write limit h tends to 0, f of a minus h is equal to f of a. Actually this is LHL and this one is RHL, and both of them are equal to f of a. So we can write one thing in combination of these thoughts, that limit h tends to 0 of f of a plus h is equal to f of a is equal to limit h tends to 0 f of a minus h. Friends, carefully look this relation. Actually this is LHL and this one is LHL and this is RHL, and both of them are equal to f of a. What is fa? That means the value of the function fx at the point x is equal to a, at the point x is equal to a. So when LHL is equal to RHL is equal to value of the function at the point x is equal to a, then we can say that the function fx is continuous at the point x is equal to a. Okay, now we shall see the graphical interpretation of the continuity of functions.